Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Matrix lab. This is the video number 139. We have been discussing in the previous video the following. While still working with troubleshooting Windows using Microsoft Sysinternals suite, uh, we have seen a lot of scenarios created by Claude 3.7 Sonnet. Some of them are created by the AI itself uh, from its database, and others are cases that are already published in a PDF called Troubleshooting Using Microsoft Sys Internal Tools, which is this PDF is created by the creator of these tools, Mr. Mark Rosenbench. We have seen until now about maybe 30 cases explained by Claude that was in Mr. Mark Rosenbench PDF. I asked AI to do so to re-explain it in simple terms to make it easy to understand. There is a lot of ways you can read these cases through the PDF. You can go to his channel, Mr. Mark Rosenbench. Rosenbench have a channel. You can see some YouTube series called The Case of the Unexplained. Here he is putting in his podcast or video podcast the cases that was solved using his tools. Anyway, we will continue with the cases again. Let me or continue from where we have stopped the last time. We have stopped at a case called the WinWebSec scareware. Let's analyze Leo and Maya. We know these two from our previous videos. Leo is I think the senior, and Maya is the junior. Okay, let's analyze a common senior and junior IT. Let's analyze a common type of malware called scareware, especially the WinWebSec family. These pretend to be security programs and claim your computer is infected, then demand payment to clean the non-existent infection. I have seen a couple of these in my entire life career. I have seen some of those. So this is a scare where we can do a simple thing just to uh, make it more. So I think I'm still continuous the free, so I think I don't have the search one, so we can tell him to explain the different types of malware and compare in a table and give statistics about each one of them, which each one of them the percentage of infection. Let's see how this will go with this one. So we have types of malware. We have a virus, we have a worm, we have a Trojan, we have a ransom, we have a spyware, we have adware, we have rootkits, file malware, keyloggers, uh, cryptojacking, hybrid malware. So he didn't tell us the scareware, okay, but we've seen here that these types we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe 11 types of malware. We have seen virus infects programs, replicates when host app runs, real world scenario virus, 13% of the malware infection globally, 53% spread via exe file. This is a good thing. Worm self-replicates and spread across networks. Something like for the Iranian virus, we have seen this in the previous video, include a multi-category malware like Stuxnix, Trojan disguised as legitimate software tricking users. Emomit 58% of all malware infections are Trojans. So we have 13% viruses, 58% Trojans. Ransom encrypt data, demands ransom payment. something like Robinhood. 10% of data breaches involve ransom. 78% US orgs phased email-based ransoms in 2021. So we can see that maybe the most one is the Trojans. Spyware collects user data secretly. Dark hotel common but specific infection percentage not available. Adware display unwanted ads. 48% of mobile malware is adware. Okay, rootkit grants remote control with admin privileges, something like this. Difficult to detect, no specific infection percentage available. Fileless malware operates in memory, use legitimate tools, something like this one, up to 10, 10 plus more successful than traditional malware. There is no percentage. Keylogger record keystrokes. Keybot, no specific infection percentage. Cryptojacking mines cryptocurrency using victims' resources, increased by 163% in 2020. Hybrid malware combines multiple malware types, no specific infection available. Additional malware statistics. Globally, malware attacks are increasing with 6.6 billion documented attacks in 2023, a 10% rise over the previous year. Infection rates by country. 47% of Chinese computers, 42 in Turkey, 39 in Taiwan are infected with some form of malware. Mobile malware infections are significant. 47.15% of infected devices are Android phones, 1 are iPhones. Email remains a primary delivery method with 46% of malware sent via email. Ransom attacks mostly target Windows system, 85%, with fewer of Mac and mobile devices, 4%. This is the over thing. Let's tell it to tell us what is the scareware. Let's. So there is something called the Windows 6 scareware. Let's tell him uh, what is. Let's see if he will answer this. So you see that WinWeb6 scareware is a type of scareware malware that targets Windows users by genetic fake security warnings that imitate legitimate antivirus software, or else it tricks users into believing their computer is infected with virus or malware and urge them to purchase fake antivirus or disinfection software to fix these non-existent problems. This malware uses social engineering tactics to create fear uh, and urgency, often bombarding users with persistent pop-up warnings about dangerous files or threats on their system. Scareware variants such as Spy Sheriff and Smart Fortress exemplify this behavior by repeatedly warning users of fake threats and pushing them to buy useless or harmful software. Spy Sheriff, this is one of the variants or sub things, or this is like this is the main program and sub programs from it, or programs behaving like it. Spy Share, for example, is particularly difficult to remove because it hides its component in system folders and blocks administrative tools. Sometimes WinWeb6 scareware also tries to convince users to disable real antivirus programs or firewalls, making the system more vulnerable to further infections. In essence, WinWeb6 scareware does not solve any real security issues, but instead uh, extorts money from victim and may install additional malware, steal personal information, or degrade system performance. Key characters of WinWeb6 scareware: legitimate imitates legitimate antivirus warning, use fake pop-ups to scare users, urge purchase of the fake security software, employs social engineering and fear tactics, can disable real antivirus firewall protections, difficult to remove due to hiding in system folders, may install further malware or steal data. Example variants: Spy, Sheriff, Smart Fortress. Recommended action: do not click on suspicious pop-ups, shut down the computer if overwhelmed by warnings, run a scan with genuine antivirus software to detect and remove the threat. This type of scareware is a classic example of deception software designed to exploit user fear for financial gain or further compromise. So scareware from its names, it focus upon scaring the user, okay, and deceiving him to buy something or to install a software. Okay, so this is one good thing about it. Let's try to continue. So we have a case like that. How does this malware work? We will submit its behavior in a controlled virtual machine. First, let's examine the executable with sig check and strings. This will make sure if this software is signed or not. SegCheck shows it has no digital signature or version information, and running strings, another software that goes inside the program and see if there is any hidden text or any hidden instructions. Okay, shows no readable text strings, both suspicious signs. When you use strings, you should, even if this is a program, there should be something here. Okay, anyway, so if it is not signed, then this is one warning we need to focus on. Let's see what happened when we run it. Leo runs the malware in a VM while monitoring the process monitor, process explorer, and VM map. This is for, I think, the virtual machine memory, I think, and process monitor. We know process explorer and process monitor. I think VM map. Let me remember what is VM map. If we go to there and tell him VM map, let's see VM map. So I think I remember it. This is VM map. This is a process virtual and physical memory analysis utility. It shows a breakdown of the process committed virtual memory types as well as the amount of physical memory. So the virtual and physical memory analyzation. Okay, so this seems to be the program. It's analyzing the virtual memory and the physical memory. Okay, both of them. Okay. Okay, so let's see the case and how this will go. So upon execution, it copies itself to the user's profile with a random file name. So it copies itself to the user profile files like documents or so and so with a random file name and displays fake warnings claiming the system is infected. They examine the process explorer output. It doesn't show up in any of the normal auto start locations in auto runs, so it was not catched by auto runs. How does it persist after reboot? If you try to start any other program, it immediately terminates it and shows a fake virus warning, making the computer essentially unusable unless you pay. So this is it. If you try to run any other program, it will terminate it and tell him this is a virus warning. That's devious. How do we remove it? I think we need to go to the safe mode. Okay, let's put into safe mode with command prompt to bypass its protections. In safe mode, they run auto run. Now we see its persistence mechanism. It creates a run once entry in the registry. Okay, they look at the run once entry in auto runs. Process monitor boot logging. Again, we can run a process monitor boot logging feature. Reveals it's create this entry right before shutdown, while it is likely an attempt to avoid detection by anti-malware during the active session. So that's a clever attempt. So he will put himself in the registry when the system is shutting down. So this is a good thing. It will not do it while the system is operational. It will do it when the system is shutting down. So to clean it, we disable the entry in auto runs and delete the executables. Exactly. Safe mode bypass its protection and allow us to remove it completely. They demonstrate the removal process. This analysis really show how these scams operate and how to defeat them. Yes, and it demonstrates how Sysinternals can reveal the complete life cycle of malware from installation to persistence mechanism. So now we have a way that this scareware works. Okay, so this is a good case, I think, very good one. We can go to the next case, which is case 32, the runaway GPU. Here is an unusual case. A user noticed loud fan noise from their computer even when it was idle. When they checked Process Explorer, CPU was minimal. Uh, if it if the CPU wasn't busy, what was causing the fan to run so hard? The user noticed that the GPU mini graph in Process Explorer toolbar was showing higher than normal activity. So they added a GPU column to the display. They look at the process explorer with the GPU column visible. A process called Java SH2XE was consuming nearly 100% of GPU. This is the graphic card, okay? While using almost no CPU. What is GPU? The graphical processor unit is a specialized processor for handling graphics and certain types of calculation. I think this is a crypto mining thing. Okay, modern GPUs are very powerful and can be used for tasks beside displaying graphics. What was the process doing? Well, this seems to be a crypto mining process. The process has no icon. This process uh, no description, no company name, typical signs of malware. After uploading it to virus total, it was identified as Bitcoin mining malware. So this is the thing. What is Bitcoin mining? Bitcoin is a digital currency. Mining is the process of performing complex calculations to validate transactions and potentially earn new Bitcoins. It requires a lot of processing power. So some malware secretly use victims' computers to mine Bitcoins for the attackers. So it was using the GPU to mine cryptocurrency without the user knowledge. Exactly. GPU intensive malware wouldn't show up in the traditional CPU monitoring tool like Task Manager, but Process Explorer GPU monitoring features revealed it immediately. How was it removed? The user simply terminated the process and used autorun to remove the startup entry it was launching in the boot. I never thought about malware that targets GPU specifically. Leo, it's becoming a more common as cryptocurrency gain value. This is why comprehensive monitoring tools like Process Explorer that can track all system resources are valuable. Let me try to open the Process Explorer just to see the GPU section here. So if you go to Sysinternals suite, and then we can go to the Process Explorer uh, program. They run it as administrator. So let's see the GPU. So I think one of them is related to the GPU. This is for the CPU. This is for the system comment. This is for the physical memory. This is for the I/O hard disk. This is for the GPU. So we can see here the GPU. Okay, here you go. This is for the GPU usage, CPU dedicated memory. So this I think for the GPU processor, okay, and this is for the memory. As we can see here, this is the view individual GPU engine usage and select engines used for GPU usage calculation. Anyway, you can see here this is the summary. Okay, we can see that we can add if I need each one of these processes and how they use my graphic card. I think we can add select columns. First, I need to remove a CPU history. Just wait for a moment. Where is the CPU here? I think I have already. Let me process performance CPU history. Here we go to the process GPU. We can here add GPU usage. Okay, and then we can see here like this one. So here's something like GPU usage. We can see here if there is any usage concerning the GPU. We can see that from here, okay, or we can see it from the this one. Okay, so we have both, we can see them. Okay, so let's close this one and then let's continue with the case. So this is a good thing. We can now we have seen two cases that are typically we can see in our normal operation. Now we see case 33, the unexplained FTP connection. Leo, in this case, a company discovered that Exchange server was making outbound FTP connections to unknown external servers. How did they discover this? After their anti-malware solution alerted them to cleaned malware, they checked firewall logs and found hundreds of FTP connections dating back several weeks. Okay, so there is a malware infection and they have cleaned it, but it was making connections to external IPs before the removal. How did they investigate? They used Process Monitor, with its network monitoring capabilities enabled to capture a trace of activity. The examine process monitor output showing FTP activity. The process tree in Procmon showed 17 FTP processes and launched during just a 5-minute capture, most of them short-lived. So in the process monitor we can see external connections. Okay, this is a normal thing. Okay, we can see that. What were these processes doing? Leo examining their command line revealed half we running ftp.exe, which just displays help text, while other used parameters like -i, -s to run automated ftp commands from a file named j. So the whole commandlet is they look at ftp command file content. So there is a file called j, okay, which will be run by the ftp. It is automated. This file contains the underlying information. Open so and so. He will open a website. What I don't know here, I think he will copy a program or something. Let's see here. This commands connect to specious domain, logged in with credentials, and download executable files. So this seems to be logic. What was launching these PDF? What was launching these FTP commands? The parent process was CMD with a complex command line. When broken down, it was creating directories, creating the FTP command file, running FTP, then creating a batch file to execute the downloaded files. So it was downloading and running malware automatically. Process monitor network monitors network monitoring showed SQL Server accepting connections from external IP addresses in countries known for cyber criminal activity. You look at the incoming connections, a security revealed. Let me see something first. I think in the Procmon there will be some. Does it will give us external connections? So here, I think. I think here I have some, or I have age. Okay, and I think it will give us. Let me first try to maybe stop or tell him to filter age, for example. So for example, no, this is Microsoft Edge. So maybe I'll try to stop the capturing, and then let's see. Here is saying that you can see network connections from here. Yes, let me see that. Process tree, find registry, file system, network conductivity. So here show all of these are there. Show network activity. So where is the network activity? We can see from here. Show network activity. If we can tell him select columns, where is the network activity? We have image, sequence, process. I think here he will put them automatically, for example. Yes, here I think in the result, maybe this will talk about it. If we go further, where is the network? If you can see here. So I think we can tell him to filter by age. How I can filter it? Filter. Let's see. I need to filter the process name. Let's see if we can. Age is age. Let's see if this will do. Apply. No, this is not age. We can reset. Apply and OK. So I think there is another name for it. Maybe we can go deep. Explorer, we can see. I think it should capture Microsoft Edge. If we go further, we see Explorer, we see Endpoint, we see, for example, Firefox. Okay, I think we can work with Firefox. Let's, for example, tell him to filter the process name is Firefox, because I think I'm opening a website through it. So let's see, it will give us the conductivity. Again, I don't know why it's not getting, maybe I'm typing the process name not correct. So we will reset, apply and OK. Let me try to see, maybe when we can type Firefox, let's see if it will search it. So he's saying that you can see here the network connection. Okay, anyway, so I will disable that, but you can see this from the Procmon, and we have seen how this is done. So a security check revealed the SQL Server had an administrator account with a blank password, mixed mode authentication enabled, and the XP command shell extended store procedure enabled, or serious security misconfiguration. So this is um, he is connecting, also monitoring SQL Server accepting connections from external IP addresses in countries known. So there was a problem because I think they were uh, stealing data from the SQL Server and uploading them, maybe. So no, I think here he have already downloaded a file from an FTP server, and then this file is stealing data from a SQL server by using the mixed mode authentication of the SQL Server. There is a weak point when you install a SQL Server. There is a local user to access the SQL database called SA. By default, it doesn't have any password, so the hacker can use it to access the SQL Server. Okay, so I think this was the issue here. And the XP command shell extended store procedure enabled, all serious misconfiguration. So there is a problem with the configuration of the SQL Server that enabled the malware downloaded from the FTP server to steal data. So anyone could connect to their SQL Server without a password. Yes, and once connected, they could run commands on the operating system through XP command shell. It's like leaving your house unlocked with a note saying the valuables are in the bedroom. How this was fixed: the server need to be completely rebuilt with proper security configurations, including strong passwords, proper firewall rules, and disabling unnecessary features like XP command shell. Okay, I think this is a feature. This is during the area of, or the era of XP. Okay, anyway, I think this is also a case, and it was exposed or solved using a process monitor. So all of these are cases that seems to be good. Now we have case 34, the misconfigured service. Let me see how much time we have. So we have 28 minutes. Let's see case 34, the misconfigured service. Here is a security focused case. During a security assessment, access check revealed unusual permissions on Windows service. So this is another utility that you can use to check permissions on different folders and services. What made the permissions unusual? Most services grant administrative access only to administrators, system user, and a few other privileged groups. To identify services with non-standard permission, they used access check with a special filtering option. What is this one? SD, so and so and so. This command shows write permissions for all services, filtering out system, local services, network service, administrators, server operators, backup operators, and trusted in store, or accounts that should have normally have access. So let me see if I can use this one and try to run it from my CMD. Uh, let's see if there is any services that have unusual permissions, is not recognized as an operational one. I think, uh, let me see something here. I think we need to go to access check. I think this is it, and then press enter. So SID, I think there should be, this is not the correct syntax. SID so and so and so, trusted installer. Okay, so I think this should run maybe in PowerShell maybe. Let me try to see that. If I go to, let's try to make it from the PowerShell. Okay, let's do exit, and we can open PowerShell. Here you go, and try to run it. Maybe run like this one and do like this, and let's see if we can do that. Access check, but there is something here again strange. This could not be done. Okay, the parameter missing argument. I think there is something here. Maybe removing the S one, maybe like this one. No, I don't think so. Okay, I think how to do it, but let me do CLS. I think first we need to do something. We need first to get the first line. So this is the SID, trusted installer. So let's see this. Maybe we can copy something like that. Let's do like this. Again, this seems to be strange. I think maybe we need to comprehend this. Let me try to correct it. Okay, let me see. So we can go like this and copy that and tell Grok to uh, correct this line, this script to work. Let's see if this will work. Uh-huh. So basically we are trying to use access check to see if there is any service that is running under an malicious user account or any other thing. Let's see first if this can be fixed. Okay, let's see, maybe I can also ask ChatGPT to do that. Okay, so let's do this and see also Gemini if this can work. Let's see. So should be closed with a quota. I think this was the missing one. Okay, so we should have it by quota. So this is the correct syntax. We need to close it and then do something like that. Okay, let's see if this will work. Now I can go to CMD and try to run it, and then let's see if this will work. Now we can see any services that is running under. So now we have it. Now but strange here, it got me all of, let's see here again. So no, I think this is not correct. uh, he should focus on these. Okay, he put them on two lines. I think this should run maybe from partial. Let me see. So if we tell him, or close this one and then open PowerShell, we have PowerShell. Let's do PowerShell again and PowerShell. Okay, and then run this one and see if this will do. Again, it is not working as intended. So it's saying that there is a problem. Okay, he cannot accept the SID here. Okay, so he's not taking this and working with them. Okay, so this is a value. This should be retrieved by access check.exe, but I don't know why it is not working. Okay, so this seems to be not working as intended. Let's see if should work with multiple SIDs. Okay, let's see. Let's correct a provided one. Okay, let's see what is the correct. He will give us the correct syntax maybe. Let's see this was correct script. Now I think that's it. This is a batch. Okay, and I think this could work. Let's go and see. If you open CMD, so here is the corrected one, set SD so and so, and then find the string. Let's see if this will work. If you go to CMD and try to run it like this one, okay, and run, and then let's see if this will work. Let's see this. Cannot open, cannot open, cannot open, cannot open. So Windows checks -C find. So I think here he cannot. But here, where is the commas? Maybe. Okay, let's see. Again, we cannot. Okay, this is not correct. Let me see if we can do this. So how can we do this? Let's see. So he's giving us. This is. Okay, so there is a batch file. So you can do this using a batch file, or you can use a PowerShell script. So let me see, maybe if we can take this PowerShell script. Let's close this one, maybe exit, and try to open PowerShell ICE and tell him to run like this. And let's see if we can work with this one. Control V, and let's see. But here, specify if not in the system pass, specify the pass. It is in the system pass actually. So let's see when I run it. So okay, I think this worked. Let's see this. So it's checking for services running invalid account name. So here you see S51 invalid account name. This is not account name. Checking permission, invalid account name, invalid account name, invalid account name. I think this is not correct. So he is giving the services that are running under trusted installer. This is strange again. Here he is talking about local system, local service, network administrators, server operators, backup operators. So saying invalid. Uh, Strange. Maybe he is not recognizing the SID of those. I think server operators. I don't have something like this in my local group. Let me try to see. Maybe I don't have them. Let's go to computer management. I know I don't have server operators. Let's go to local and groups. I don't have. I have backup operators. There is no server operators. Okay, so there is backup operators. We have administrators. We have. So I have only those. Okay, backup operators and administrators. So here we have these only limited on domain controllers. I have backup operators. Okay. Net. I have administrators. So again, he doesn't feel or he doesn't get invalid account name. Strange. Maybe the numbers is not correct. Okay. How we can know? I think I have here. We can use another utility to know the SID of a certain group or user. So we can, let me try to see. This is some troubleshooting we need to do. We go to CMD and then we can run like this one, and let's see. We can tell him PS something. There is a utility called uh, PS SID, I think. ESID, I think. Okay, let me remember. I can go to the utility itself. Okay, so we can go there and see. We need to know the SID of the groups. So there is a utility in the sysinternals that can do so. Something called PS. Okay, something called. Let me get the name exactly. Called. Uh, I remember it's something called uh, SID. Okay, let me remember. PS SID. Let me try to. Yes, PS get SID. Okay, so this is it. And PS get SID. Okay, so let's get the name in specific. PS get SID 64.exe, and then we can put the name of the group administrators. Okay, and let's see if we'll get the SID. So this is the SID, and this is strange. It's actually correct. If you go to the they go to the number, it is correct. This is correct. So there is a problem with the script. Okay, so it's saying invalid count name, even though this seems to be correct. This SID is correct. So I think there is a problem with the script again. I think let me try to maybe correct it. If you go there and try to uh, explanation, let's see if we can give him the output. So let's get this one. Okay, let me try to uh, get this one. Checking. Let me try to get. So he only succeeded in getting the services that are running under trusted installer, but the other ones are not correct. Let me try to copy that. Just a moment. Okay, let's try this. I have this. output from your PowerShell script. Okay, let's see this. So I think the script, there is a problem with the script. So I think you will put the names instead of the SID. Okay, so let me see if this will work. So we can put the name instead of the SID. Now we can copy that and try to go again and tell him to clear, and Control A and try to put it like that. Now we can see he had already put the names. So let's try to see if this will work. Okay, so now so I think this is correct. Now he is giving us some he succeeded in a couple and some, let me see. So again he is giving us each service. Let me try to get it from the beginning. So now we can see that for example, for the system, all of these services are running under system. Some of them I'm running under trusted installer. So for backup operators, there is no objects. As for server operators, it's not currently on my PC. And now we have the rest all running under these services. Okay. So I think this is a good thing. So you can know which services are running under which users. But again, here is talking about something, talking about source permission for all services, filtering out system, local, so and so and so, and trust all accounts that should normally have access. I need to do the opposite. What did they find? One server stood out. The SMP service had right permission granted to every one group. So I need the opposite. I need filtering out system. Let me try to give him some prompt. I need the PowerShell script to give me services that are not running under the local groups to filter. Services that are not running under the local groups or local users stated in the script. Modify to apply that. So let's see. But again, does this, okay, it will use access check, but let's do that. So now we need to get if there is any service that is not running under the normal So okay, the script will service running account as specific local users, like so domain users, managed servers, virtual. Might need to add specific. Will serve configured to run as the script will list services configured to run as accounts like specific so on so it will let me get the script and try to run it. So we'll tell him like this one, and control A and then control C, then control V. So let's see. uh, Here standard defined, so here we can see what it, okay, defined expected standards are local. Okay, local service, uh, NTF trusted installer. uh, so okay, okay, so where is the access? uh, it's not using access check. Okay, this is not what I need. So anyway, we are trying to get, let's see if this will work. So okay, it's searching within not running under standard accounts. Standard accounts considered local network. So we can add here things that are not running. So for example, I need services that are not running under local service or network service. So for example, here he is talking about display. These are running under which? Uh, so let me get one of these services. So running under non-standard accounts. So for example, let me get one of these. As for the Bluetooth service, let me try to see maybe services here. So let's see here, Bluetooth service. Let's go like this, Bluetooth service, support service. I think this is it. Let's see. Sorry, let's see the syntax. It is Bluetooth user service. Bluetooth user service. This is the one. And login as this account. So there is no account to run it. Strange. This is not local system, so it's not running under local system. It's manual. So this seems to be good. As for example, printer workflow user. Let's go to printer workflow user. This is one, and again it is running under account. This seems to be not the local system. So this seems to do what we are talking about, is trying to get the services that are not running under normal things. So we can add here to the script, add the things we need. So we can add administrators, so and so, define this context, so and so, filtering out but illustrate the original context. So we can add administrators using the standard service account approach is generally more reliable for finding out layers. So anyway, so this is a way that we can check uh, check who is, or the service is running under different users. So let's close this one and go to the case. So this didn't work anyway. So it's saying that there is a service called SMB service that has write permissions granted to everyone group. Okay, so here to examine the detailed permission. So for example, if I need to get a permission for a certain service, Let me, for example, use this copy and, for example, tell him CMD. If I try to get the service details for certain service, let's try to SMB, for example. I have a something called SMB. I think there is no object found, so let's try to get a service that is currently running. So maybe I can get something like maybe Avera Phantom. Let me get, this is Avera Phantom. So let me see if I can get the permissions on this one. So we can do like that and put like this. So here we can see this is the permissions on this service. So we have the owner, NT authority system, we have access allowed, we have administrators, we have interactive. Let's continue with the services. Interactive, NT authority service, and we can see here the permissions may be query status, query configuration, interrogate, enumerate dependencies. So this seems to be good. Read permission everyone, fail access, service all access. Anyway, so this seems to be a good utility. Now we can go and see the, see, this is everyone. So everyone have full control over this service. Everyone have full control. So this seems to be not logic. Notice that everyone had granted right DAC and right owner permissions, allowing anyone to change the service permissions. What's everyone? Everyone is a special group that includes all users who have access to the computer, including anonymous users, basically anyone. Giving everyone right permissions to a service is extremely dangerous. What was the impact? This was actually a backdoor left by the attacker. Anyone could connect to the server, change the SMB service configuration to run arbitrary commands as system, and maintain control without needing privileged accounts. How was this discovered? Access check filtering capabilities were key. By filtering out expected permissions, the unusual ones stood out immediately. The backdoor was particularly dangerous because it would persist if administrator passwords were changed. It didn't require privileged credentials to exploit. Access check helped identify a subtle but critical security vulnerability. Yes, and this is a perfect example of how these tools can be used for security auditing, not just troubleshooting. It's like having specialized equipment that can detect hidden doors in what appears to be a solid wall. Uh, uh, Let me see access check. Uh, okay, anyway, so I think now we have a clear view how we can get the permissions on certain services. So I think we can stop at, or we can take another case. This is Sysinternals blocking malware. In this case, the system was suspected of being infected with malware, but when user tried to run autoruns, procmon, procsec, or any other thing, they would immediately exit. Blocking malware. This is a clear sign of malware trying to prevent analysis. Even more suspiciously, when the user tried to open a file text named Process Explorer with Notepad, it was terminated immediately. So this is a good case. How clever. The malware was blocking anything that might detect it. How did we work around it? They realized that the malware was popularly using the Windows enumeration functions to find windows with certain titles. These functions only return windows on the same desktop as the caller. What's a desktop in this context? In Windows, a desktop is a secure environment where Windows and other UI user interface elements exist. Windows normally have several desktops. The main one you see, the login screen, the screensaver, and so on. Programs on one desktop can't easily interact with other programs on another desktop. So they use a different desktop to bypass the malware detection. Exactly. They ran the sysinternal desktop utility to create additional virtual desktop, so you can use another virtual desktop. Then they ran procmon on the second desktop where the malware couldn't detect it. They demonstrate using desktops to create a new virtual desktop. There is another utility called virtual desktop. On the second, this is from the sysinternal tools. I think there is this is does the same. If we go to like this, you can have another, you can tell him to create another desktop. Okay, so this is it, but there is already something called virtual disk, or something called virtual, I think. Here you go, we can, there is something called, it's talking about desktop. So we can see here, this is called desktop. We can have something like this one, the same we have like this. So this will be able to run Procmon and observe unusual registry activity from when login, checking a strange registry key every second. They show the Procmon output highlighting suspicious registry activity. Autoruns then reveal the malware was registered as a Win login notification package, loading a DLL into the Win login process. They look at the suspicious autorun entry. How did they remove it? First, they tried deleting the entry in autorun, but it kept coming back. So they directed Microsoft Security Essentials to just scan the specific DLL, which successfully cleaned it. So this utility was the key to bypass the malware defenses. Yes, a creative use of Sysinternals utility to enable the use of other sysinternal tools for malware removal. It's like using a secret tunnel to get behind enemy lines. So I think this is a very, very good case. We can stop at this case and continue with the upcoming video with Godwill. So hope this is informative to you all, and thank you all for viewing. Thank you so much.